There are several reasons why bees swarm. 1. To increase the total number of colonies. This increases the species and enables it to spread in a locality. 2. To create genetic diversity and thus create bees that are adapted to the local environment. 3. To respond to overcrowding in the colony. Genetic diversity enables colonies of bees in a locality to have a better chance of surviving changes in that locality. Some colonies might die out because they are not adapted to the changing conditions. But because there is genetic diversity, certain other colonies are more likely to survive when conditions change. In this way, the species is able to adapt to changes in environmental conditions and food supply. It's fairly common to observe that a swarm collected in the spring or summer in one year will, generally, not generate a swarm itself in the same season. However, if it comes through the winter in good shape, it will expand rapidly in the next spring and is likely to swarm in the second season. For example, the spring in the UK of 2022 has been very warm since March. The swarming season started early in April, and there were many primary swarms in April and May, where normally these would be in May and June. The colony that is set on swarming prepares queen cells and raises several new queen larvae. The old queen slows in laying to slim down ready for flying out. If the weather during spring continues favourably and there is the prospect of ample nectar supply in the next few weeks, and when the queen larvae are mature and about to emerge, the old queen leaves the colony with a large entourage and departs some distance from the old colony. The distance varies greatly from a few yards to hundreds of yards or more. The swarming bees cluster for one or more days by attaching to a garden ornament or tree branch. The old queen is at the centre of this mass of the swarming bees, kept there by the bees attracted by her pheromone scent. Scout bees are sent out from the swarm to find a new cavity in which to establish as the new permanent location. After one or more days, the swarm will move into this new location and commence comb building as quickly as possible. Foraging bees will return with nectar and pollen to provide the food required for feeding the queen, wax comb building, and for food storage. This is so that the queen may commence egg laying and brood rearing as quickly as possible. In the following months of the season, foraging will establish sufficient stores to survive the approaching winter. While all this is happening to the swarm, back at the old colony, the bees there are raising a new replacement queen. Usually, they raise several queen cells. The first virgin queen to emerge battles for dominance with any other virgin queens until only one remains. Alternatively, caste swarms containing a smaller retinue and with one of the virgin queens may also be emitted from the old colony. The one remaining virgin queen at the old colony flies out to meet and mate with local drones at drone congregation sites. The virgin queen will not just mate with drones that are part of the old colony, but will also mate with drones from other local colonies. She mates with several drones and as many as 20. This activity is the one that creates genetic diversity in her offspring. She stores the semen from the many drones in a sac called the spermatheca. Eventually, she commences egg laying, fertilizing each egg laid with her stored sperm. The old colony has thus replaced the old queen with a new young one. She lays eggs in her youthful strength creating worker bees and drones, which are genetically diverse from the existing workers which had been created by the old queen. The foraging bees of the old colony established sufficient stores to survive the coming winter. Now we have two healthy, well-established and independent colonies. So the colonies are continuously protected and the species has been advanced. And that's the purpose of swarming.